All right, I think it's 10 o'clock, so go ahead and get started. Good morning, everyone. Thanks for coming out. No, it's the last day of DerbyCon and late night last night, so I appreciate everyone getting up and making it out. This is abusing Linux trust relationships, authentication back alleys, and forgotten features. So in this presentation, I'm going to be walking through a example pen test in a lab environment I created just to demo some of the tips and techniques that I've used in the past for Linux post-exploitation and pivoting around Linux networks while trying to remain as undetectable as possible. We've got a lot to cover, a lot of information in the slides here in the next 25 minutes, but quick agenda. There's a brief introduction about who I am and why this talk. And then I jump right into it, and we're going to start talking about exploiting authentication and trust in these networks. And specifically, I'm going to talk about sudo, Kerberos, and SSH, and some of the fun you can have with all three of those. At the end, there's a demo, and the demo is going to combine a lot of these techniques and ultimately culminate in bypassing and getting around Duo's two-factor authentication and get into a very protected and segmented production network that's using that. Then hopefully, time permitted, if I don't go too slow here, we can have time for some Q&A and discussions at the end. So who am I? My name's Ronnie Flathers, and I'm a senior consultant with Cisco. Before Cisco, I was with a company called NeoHapsis. And at NeoHapsis and at Cisco, I perform a lot of internal pen tests, the technical stuff, but also get exposed to a lot of the higher level strategic and kind of network architecture planning and work with a lot of different organizations. Lately, I've been seeing, and we've been doing a lot more tests in Windows-less environments. And these are internal penetration tests where your standard tool sets don't work, and we don't have PowerShell, which is a fan favorite here at DerbyCon. And we've seen this in a lot of DevOps and cloud infrastructure environments where everything's done via Linux and SSH keys and DevOps and Ansible tools like that. So after doing a lot of these pen tests and talking about after the fact with the clients and showing them what I was able to do and then having remediation strategy discussions, I realized that a lot of people weren't really aware of all you can do in a Linux environment with just some of the standard tool set that you have. And after talking about it with some of my other coworkers and red teamers, I realized that they weren't really familiar with some of the techniques also. So that's where this talk was born. I decided to put a lot of this information into slides to share it out there. Now I'm going to jump right into it, and for the rest of the talk, we're going to be pen testing this example environment that I created. And it's a really simple environment, but it's entirely based off architectures that I've seen organizations implement before. And this is called ropnop.lab. And in this organization, there are three different network segments. There's the corporate network, there's the dev network, and then there's a highly protected production network. And the production network is further segmented with two-factor authentication. There's two users in this network. There's Mark and there's Patrick, and they have two different privilege levels. Mark is, say, an administrative user. He doesn't have many privileges, and he can't actually leave the corporate network. Patrick, on the other hand, is a developer, and he has rights to get into dev, and he has rights to get into prod to make changes when necessary. Now, this organization has some shared common services here. There's no Windows in this organization, but they are using LDAP, DNS, and Kerberos. One box here that I want to talk about, because I've seen a lot of organizations have something similar, I've called TS, and it sits inside the corporate network, and it's a shared use box where employees can log into and get a Linux environment, and they can use this box to run tests or stage code or store things on. They just have access to this box. And my company has a few boxes like this. My school had a box like this where all students were able to log in to a Unix box and get access to it. So I've seen a lot more, especially as DevOps has become a lot more prevalent in organizations. Now we're going to assume, for the sake of this pen test, that Mark gets compromised. A lower privileged user has had his password stolen. What's the worst that could happen? That's where we're going to start off on this pen test example, and I'm going to dive right into it. But before I do that, just looking at this kind of show of hands, who here thinks that this is a pretty, although simple, but a pretty sane and secure network layout and organization? Yeah, I think so too. If you look at this, they're doing a lot right. They have segmentation in place. They're enforcing access controls. They've got 2FA on their sensitive network, the production network. They've got users with differing privilege levels. They're doing least access here, least privilege access. They're doing a lot right. But there's one area where they are weak, and it's where these trust boundaries kind of get blurred between users with different privilege levels, and that's that TS box right there, as we'll see. So jumping into it. Cannot stress enough how important reconnaissance is. For red teamers, you need to know exactly what you're working with when you start doing an attack scenario. And you need to learn to love those informational findings that I mentioned earlier. LDAP and DNS are treasure troves of information and my go-to for great information about a network. DNS can tell you what services are running and where they are on the network, and LDAP can tell you who's using them. So these 3 dig commands here are just some example DNS queries you can look up for serve records, and they'll tell you where the LDAP servers are, where the Kerberos servers are, and the text record there at the bottom will tell you what the Kerberos realm is. So with those 3 commands, we have a pretty good idea of where authentication is being handled and where LDAP is. Once we know where LDAP is, we can actually just do LDAP queries to find out even more information about it, either through unauthenticated binds or if we have a password through an authenticated bind. This LDAP query will dump out all the information for ropnop.lab and tell us where boxes are located, information about those boxes, what users are on the network, what groups they're in. So through some of this recon, if we have, say, Mark's password, we might realize that, okay, Mark doesn't have many privileges, but Patrick, on the other hand, does. And we'll keep that in mind, knowing that Patrick might be the one we actually want to try to compromise down the line. So I've heard a lot of organizations say that they're trying to migrate away from passwords, that passwords are weak and we don't really use passwords in our environment because we're fully Kerberized and we use SSH everywhere. So even if you get a password, well, you can't log into anywhere because we don't use password authentication. Slight problem with that, though, which is Kerberos is password-based. So if we SSH as Mark from our Kali box here and we try to get onto that TS box, we can see that we get permission denied. And that's because password authentication is disabled. But we see that GSS API is enabled, which is Kerberos for SSH. Now through that DNS recon a step ago, we know where the Kerberos servers are, so we can actually configure our Kali box to talk to those Kerberos servers and authenticate to the Kerberos realm, which is ropnop.lab. So we can do a kinit command to check out a ticket for Mark, and we authenticate with Mark's password, which we've got through, say, phishing. A klist will show us, yep, we have a TGT for Mark at ropnop.lab, and we can SSH again, but this time tell SSH to use GSS API authentication and to delegate our credentials forward. And a second ago, we got permission denied. Now we get welcome to Ubuntu. So we've just authenticated to a box using a password, even though you say password authentication is disabled. It only took a few additional steps of just knowing how the network works and being able to talk to the Kerberos server first. Now, I'm not going to talk much about local privilege escalation. There's really great resources out there and a lot of things you can look for, but I have to mention my favorite way of getting root privileges on a box, and it's the first thing I always look for when I land on a box like this, which is sudo. We trust sudo to give us root privileges responsibly, right? But it's basically just a whitelist of commands that a user can run as with root privileges, and it's handled by etc sudoers. So sudo-l is a command you can run which will tell you what you have permissions to run with root privileges. So if we log into TS as Mark and we do a sudo-l, we can see that Mark can run these following 4 commands. I don't know if everyone in the back can see that, but does anyone see any problems with some of these commands? A few people, yeah. If I was a pen tester, my eyes would light up because I can actually get a root shell from all 4 of these commands through sudo. Find. Seems innocent enough, right? You're just searching. But find has the exec param, which will actually execute a command once a file is found. So we can just find a file that we know exists and then execute bin bash and drop into a root shell. Vim's just a text editor. What could go wrong? Vim lets you execute shell commands, so we can just do a bin bash within Vim and drop immediately down into a root shell. Here's one for DevOps people, a custom script. Well, I've seen this before where the script inherits permissions that are wrong and it's group writable. So we can just modify that script and then run it with sudo root shell. This one's a little bit more subtle. On the surface, it looks like all you can do is copy logs from Apache into a backups directory. But that wildcard is unbounded, which means you can actually put in .. slashes and traverse upwards. So you can actually copy anything from anywhere to anywhere else. So I can sudo copy bin sh and overwrite some other script or binary that I also have sudo permissions to run, and then sudo run that and drop right into a root shell. So 4 different ways to get a root shell on this box. Didn't take much, was no crazy exploit, we just dropped into a root shell with sudo. Well, we've got root, so now what? Well, we've all seen the talks at DerbyCon so far. I mean, what do we do when we have system on Windows? We run Mimikatz. So we'll just wget the Mimikatz elf binary, and we'll chmod it, and then we just sudo mimikatz -- dump secrets. Just kidding. That doesn't work. That doesn't exist. We are root, though, so we can, if we want, add local users. We can change passwords. We could do something really nasty like rootkits or backdoors. But to me, these are easy ways to get detected, to trigger alarms, and or cause damage to an organization, which we want to try to avoid. So no, we need to think like attackers, and we need to think in graphs. We know that other users exist on the network, and we know that other boxes exist on the network, and we know that those users connect to those other boxes. So there's only one solution in my mind. We need to go deeper. We're root, but you can't just transfer root to another box. The question is, how do we become someone else and move to a different box? In this example, in this organization, we know that they're using Kerberos to authenticate. Well, authenticated users will leave behind Kerberos ticket caches. Now, in Windows, these Kerberos ticket caches are stored in protected memory, and you have to use a tool like Mimikatz to access them. On Linux, they're stored in the temp directory, and they're just files. Now, they do have file permissions on them, but we're root, so we can do whatever we want with them. Your default, or the default location for Kerberos ticket caches on Linux is temp krb5cc _ and then your user ID and some random characters. You can find where your current Kerberos ticket cache is with a klist command, or it's always going to be stored in the krb5cc name environment variable. If we do an ls-l on just temp kerb *, we'll see all the Kerberos ticket caches that are in that temp directory. Now, if there's a Kerberos ticket cache in that temp directory that's not expired yet, and we copy that into our ticket cache, in the eyes of Kerberos, we've essentially become that person, and we can now authenticate as them wherever we want with Kerberos tickets. So here we are root on that TS box. We've elevated from Mark, and we run a klist, and we see that we're still Mark at ropnop.lab. That's our principal name, and our Kerberos ticket cache is at temp krb5cc 10,002 random characters. We do an ls-l in the temp directory, and we see that, oh, Patrick has been on this box recently. He got a ticket, Kerberos ticket, and sitting there in the temp directory. If we copy Patrick's Kerberos ticket cache and overwrite our Kerberos ticket cache, and then run klist again, Kerberos now thinks, okay, our default principal has changed. We're now Patrick at ropnop.lab. So we just do the same thing we did a second ago, and we SSH with Kerberos authentication as Patrick, and we just jumped into the development network as Patrick, where previously Mark didn't have access to get onto that development network. So we just impersonated someone else and made another jump into a different network segment by stealing Kerberos tickets. So Kerberos is hard to configure. It's not extremely widely deployed, but everyone uses SSH. And a lot of users who use SSH will use SSH agents, and they'll do SSH agent forwarding. So is everyone kind of familiar with SSH agents and forwarding? Basically, to avoid storing your private key everywhere, when you do SSH agent forwarding, it'll decrypt your private key into memory on your laptop, and then when you SSH to a box, it opens a socket, and that socket connects back to the agent which resides on your laptop. Any further hop or authentication you want to make, it'll pass the authentication materials, the challenge and the response, through that socket all the way back to your laptop where your private key resides to do the challenge response. The beauty and the danger here is that if we can hijack this socket, we can use it to kind of outsource our authentication to a legitimate person and a legitimate SSH agent. So what I mean is if we wanted to try to authenticate as Patrick and we hijack the real Patrick's SSH auth socket, when we get a challenge from the server we want to authenticate to, we kind of just immediately pass it off to the real Patrick. It goes to his laptop where his real private key resides. It sends the response to that challenge back through the socket, and we've authenticated as Patrick from our session without having to actually need Patrick's private key because we've, like I call it, outsourced our authentication. So that socket is located on the system, and the location is in an environment variable called SSH auth sock. So to hijack an SSH socket, it's kind of a three-step process. First, you want to discover who's actively logged in. This only works if a user has an active connection to the machine. And then you find the PID, or the process ID, of their bash environment. Once you know that, you can dump the environment information for that PID and look for that environment variable called SSH auth sock. It'll tell you where that socket is located on the system. Then we just pass that as an environment variable to a new SSH connection, and when we try to connect, it'll use that socket to handle all the authentication for us. So these are the commands to do that, and this is going to be in the demo video coming up in a few minutes. But to discover logged in users, you can use who. And to get the process IDs, I like to use pstree. And so we can see that Patrick is logged in. Sorry, this is small for the people in the back. But we can see that Patrick has a bash process ID at 1979. This little one-liner here, it will dump the environment information for process ID 1979, and with a trim command, it'll pretty print it for us. And then we just grep for the SSH auth sock environment variable. And we'll see that there's a SSH auth socket in the temp directory here with a bunch of random characters. All we need to do is pass that as an environment variable to a new SSH connection, forward that agent again, and we can authenticate as Patrick into the dev network. And when we hit enter, like I said, it's going to pass all that authentication challenge response through this real Patrick's authentication socket, and we'll authenticate as Patrick and jump onto the dev network. Oh no, it's 2FA. So even if a organization might say, even if you have a password, or even if you have an SSH agent, or even if you have a Kerberos ticket, we use 2FA on our most sensitive systems. And there's no way you can get past that, right? Well, the first time I came across this, I was a bit stymied, and I had to kind of step back and think about, all right, how is two-factor authentication actually handled with SSH? How does it actually work? So two-factor authentication for SSH usually happens in one of two ways. The first is using SSH's force command. What this does is after a user's authenticated, it forces them to execute a command and kind of throws them in a jail where they have to then put in their one-time password or their PIN. But that's not really true 2FA because they've already authenticated and then you're challenging them again for another authentication. There's a few different ways to bypass that. I'm not going to go into it here because the more secure and true way to do 2FA is through an actual PAM module. So Duo and Google are two popular 2FA service providers, and they both offer compiled PAM modules that you can throw on a box and then use that for SSH authentication. Excuse me. But to understand that, we need to think, how do PAM modules work? When do PAM modules actually execute and handle authentication? They fire during the connection establishment phase. So PAM modules will ask you for your authentication, whichever way you want, when you're trying to establish a connection to the machine over SSH. Once that connection is established, they're not used again. They just go in the background and you have your active session, and the PAM module never fires again until that connection is destroyed and you try to open a new connection. Now this is a really subtle but very important thing to realize, that authentication happens on a per connection basis, not a per session basis. As long as that connection is not destroyed, the user is never prompted again, and that connection can be as long lasting as ever long the user needs that connection or session to be active. So how can we use that to our advantage here? Has anyone heard of SSH master mode? 3 people, 4 people? Yeah, it's a kind of lesser known feature that's built into SSH that is incredibly powerful and, in my mind, really dangerous too. SSH master mode allows multiple SSH sessions to share one connection. It's a built-in multiplexer for SSH. These sessions don't require additional authentication because authentication, remember, only happens on a per connection basis, not a per session basis. So you can think of it like piggybacking on an existing SSH connection. The connection is there, and we're throwing in a new session into that existing SSH connection or tunnel. So there's 3 options that control SSH master mode, and they all have to be present when the connection is initiated. Once a connection is initiated, you can open a new session on that connection through a socket with the -s command. So these are the 3 options right here. The first is control master, which tells SSH, I want to use master mode for this connection. Control path tells SSH where to store that socket. In this case, it's in the temp directory, and these variables get expanded to user, host, and port. This last option really kind of blew my mind when I read about it in the man page. Control persist yes. What this does is tells SSH that even if there's no active session, keep the connection alive. So think about that for a second. With control persist set, you can log into a box with SSH, you can do your work, you can type exit and shut down. SSH does not terminate the connection. The connection just keeps running there in the background until the next time you want to open another session on it. So how can we abuse it? Well, when I've read about it, I thought, okay, this is kind of like a backdoor for SSH. If we can trick a user into initiating a connection with master mode, it'll open a socket. We can come by later and inject a new session into that socket without needing to authenticate because the real user's already authenticated that connection for us. All right, demo time. In this scenario, we're going to start in the video here where we've already gotten onto TS. Remember, we compromised Mark's password and we jumped onto that TS box and we've elevated ourselves to root. So we're going to start with a root shell on TS. Our goal here is to get into that production network, which is protected with 2FA. So here's our root shell on TS. The first thing we're going to want to do is see who's currently logged in. So we run the who command and we can see that Patrick has a active session. So the PS tree will give us the process ID of bash for Patrick. And that one-liner that I showed earlier here is going to dump the environment variables for that bash session. And we're going to grep for his authentication socket because Patrick's using agent forwarding here. So that's where the SSH auth socket's located. We just have to copy that and paste it as an environment variable into a new SSH command. We forward that agent on, and we want to jump onto the dev network as Patrick. We hit enter, it outsources all the authentication for us. And we jump on to dev as Patrick, and we've just authenticated to him. So we're feeling pretty good. We're attackers here. Let's just try to jump onto that prod network right now. We have Patrick's agent, so let's just go ahead and SSH onto prod. Authenticate with partial success, and shit. It's 2FA. We definitely don't have access to that phone, and it's duo 2FA. There's no way we can get around it. But we think like attackers, and we know that the real Patrick does log into prod. He's going to have to eventually. So let's backdoor his SSH with master mode. So here we're opening his config, and we're telling SSH that the next time you connect to prod, use master mode, save the socket for that connection in the temp directory in a file called mwahaha, and then persist it. Keep that connection alive, because when he's done with it, I want to use it. So don't destroy that connection, persist it, and keep it alive. If we look in the temp directory now and we see there's nothing there, so now we just wait. We keep our shell alive on this box and we just wait for the real Patrick to come along. So here's the real Patrick, different session. He's doing his dev stuff and it's time to make a change on prod. So he's going to SSH as himself onto prod. Authenticate with partial success. He's got his phone at his desk in front of him, so he's going to send himself a duo push. The Duo app pops up and says, do you approve this connection to prod? He says yes. He types in his password. Now he's got a session on prod. He does his dev stuff. He makes whatever change or restarts the service, whatever he needs to do. And he exits and he closes out that session. And he goes home for the day. Now we as attackers come back from lunch and, we take a look in the temp directory. And suddenly there's a socket there called Mwahaha. So we're going to try to SSH again, but we're going to tell SSH to use that existing connection with the -s command. Second ago, we got two-factor auth. Now we just immediately open up a session, and we've got a session on prod as Patrick, and didn't even see that Duo two-factor auth prompt at all. So I'm a little over on time, but real quick, just to summarize here, this is kind of graphical of what we did, but we ended up with a session on prod as Patrick without ever knowing Patrick's password. We never had Patrick's SSH key. We never had access to Patrick's phone for the two-factor auth prompt. And I think really telling is we never used any hacker tools or things that might flag an IDS. Because what was there to detect? We used Kerberos, we used SSH, we used sudo. All this stuff is normal in that network. And then we ended up with a shell as Patrick on prod, which is also not normal or not unexpected because the real Patrick does work on prod as well. So I hope for red teamers and blue teamers alike, some of these tools and techniques really make you kind of question who and what do we trust on our network and how can we prevent and defend against these types of attacks and pivoting around our network. So thank you. I don't know if I have time for questions, but I will happily go out in the hallway and I'm happy to discuss a little more. Okay, perfect. Thanks, everyone.